Okay, welcome to a video for Math 2311, Foundations of Elementary Mathematics 2. And what I'm going to do in this video is go through 3 different statistical reports. And one unfortunate thing about statistics is that anytime someone presents numbers, there's not a standard way to do it. A lot of times within a field, there's certain standards that are usually follows, but overall, statistical reports can look so different. And you really have to sit down and read the information and figure out what perspective they're coming from and what exactly they're trying to measure. And the first one that we're going to talk about is the Nation's Report Card for Science 2009. This is summarizing the results for Texas, you'll notice up here, in grade 4, of the National Assessment for Educational Progress. That's what the NAEP stands for. And this is a test that's administered across states, and it's meant for states to be able to allow, or to be able to compare their students' outcomes with those of other states, to also compare their students' outcomes with what they've been in the past, and then finally just to see what their students can and cannot do. Now, unfortunately, this is the first time that the science test has been administered, so there's not a time comparison there. But there are a couple of things that I want to look at in this report. I'm not going to look at this map. This map's not too bad. The blue is the taste that we're looking at, or the state that we're looking at. Texas was lower on this test than 24 states, and those are the ones in green. The states in green attained a higher level on this test than we did in Texas. And then the red states are states that we were higher than. So we were higher than these states here. You'll notice that this really is a geographic thing. We were higher than other states in the south, but other states in the north tended to be higher than us. And then these states that are in tan scored not significantly different, and we'll see that term significantly show up a lot as we look through these statistical reports. What that means is the score might have been a little bit different, but it's not different enough to really say that the states that Texas had a higher or a lower score with any kind of meaningfulness to it. And then finally, there are 5 states that didn't participate, and those are the ones that you see in white. Okay, so let me scroll down here. And the first thing we're going to look at is these overall results. And what this is doing is comparing Texas with the nation. Your summary information over here is describing what's being displayed in this graph. Okay, first of all, in 2009, I'm right here, just below the overall results. In 2009, the average score of 4th grade students in Texas was 148. This was not significantly different than the average score of 149 for public school students in the nation. So on the graph over here, you see that you have 148 for Texas, 149 for the nation. So Texas actually did score a little bit lower on their average score than the nation as a whole. However, the difference between those is not very big. And there are very careful statistical procedures to go through to see if that difference is really big enough to call it significant. But we just have 148 and 149. The sample size factors in here, and these are rounded numbers. It could have been 148.4 and 148.6. We don't know, but the unrounded numbers, it's noted down here. The significant tests were performed using unrounded numbers. The unrounded numbers, whatever numbers were rounded, 148 and 149, those average scores were not significant. The statistical test was performed, and it was said that, really it's reasonable that this score just came about from other reasons than the structure of the Texas educational system somehow produces a lower average score than the nation. That's not a very good explanation for this difference, because the difference just isn't very big. It's much more attributable to just chance. Maybe Texas students, we happen to have the students take this exam that weren't quite as strong. Anyway, there's no significant difference there. And then we also say that the percentage of students in Texas who performed at or above the NAEP proficient level was 29%. This percentage was smaller than the nation. Now, they're not just saying 29 is less than 32. By saying was smaller, that's in contrast to not significantly different. This 29 is significantly smaller than 32. Okay, and that's why it has a star on it. It says star means significantly different. We'll talk about what this p-value means. But at the proficient level, it seems that there is something structurally about Texas that's producing less students that score at the proficient level. Okay, and then the percentage of students in Texas who performed at or above the basic level was 70%, and it's not significantly different from the nation, which is 71%. Okay, now something funny here to see is that if you add up these percentages, right? I have 30 plus 41, that's 71. And then if I add 71 to 29, that's 100. But then I add 1, that's 101. These are supposed to be percentages. Why did the percents add to 101? And it turns out that happens for the nation too. 29 plus 39, you can check that. Well, you don't have to check it in your calculator. It can add 1 to 39. Subtract 1 from 29. That's the same as 40 plus 28. And I know that that's 68. And then if I add 32, 68 plus 30 is 98. Plus 2 more gets me to 100. The sum of the percentages for the nation is also 100. And the reason for that is rounding. Okay, they rounded these percentages to the nearest whole number. And by doing that, it turns out in both of these categories they created 101 total percent, which is sort of funny. And you'll notice that here, the percentage of students in Texas who performed at or above the NAEP basic level was 70%. There's below basic is over here in the red, at basic is here, so they said 70%. But that's talking about the 41, the 29, and the 1, which actually adds up to 71. So the 70% is rounding when we sum the unrounded numbers. It's waiting until the end to round, and that ends up with a different result. So just want to point that out. Sometimes in a statistical report like this, you'll get something like that, that the percentages don't actually round to 100. Okay, so the 30, the 29 for the students that performed below basic, that was not significant. The 41 and the 39, notice Texas got a little bit higher that time than the nation. That was not significant. Those numbers aren't far enough apart to really draw any conclusions from it. These numbers were the only ones that were. Okay, so let's move down here, and I'm going to have to erase the screen to be able to move down. And now we're going to look at this last chart here. And our conclusions are over here. There's 4 bullet points that this report card has pointed out for us. First of all, in 2009, male students in Texas had an average score that was not significantly different from female students. So if we look over here, the average scores of male students and female students are about the same. And indeed, a statistical test was performed, and it was determined that even though these two are different, they're not different enough to throw up any flags and say that we really have something to look at here. This difference could very well have just been because of chance, which particular students took the test. Okay, and it doesn't comment on these. It doesn't comment on these. My guess is that it would have counted on them if there was a significant difference between them. In 2009, black students had an average score that was 29 points lower than white students. This performance gap was narrower than the nation. Okay, so our white students are performing at 168. Our black students are performing at 139. So that looks like a bad picture. Our black students are performing much less or much worse on average than our white students. And the difference between these two is 28, or excuse me, is 29. If you add 29 to 139, you get 168. But that's actually good news because that gap is narrower than the nation as a whole. The nation as a whole has a gap of 35 points. Okay, so our gap between our white students and our black students is lower than that of the nation as a whole, on average. Now, there's several explanations for that. It could be that our schools are just worse, and the white students are performing worse overall, and the black students aren't performing as much worse. It could be that our schools are performing better, but it's tending to boost the black student scores more than the white, or it could just be that the black students are pushed up a little bit more, the white students are pushed down a little bit more. What we're really measuring here is the gap between these average scores. We're not measuring the average scores of themselves compared to that of the nation. Okay, also Hispanic students have an average score that was 31% lower than white. That's not different from the national average of 32. Let me erase what I have here. Okay, here's our white average. Our Hispanic average is right there. The difference between those is 32. Nationwide, the average difference is the difference between those, yeah, it looks like it's 32 here. It's another rounding issue. The actual difference rounds to 31. The national average rounds to 32 in the gap. So with the Hispanics, there is no significant difference between our gap in Texas and the gap in the nation. And then in 2009, students who were eligible for free reduced price school lunch had an average score that was 31 points lower than students who were not eligible for free or reduced price school lunch. This performance gap was not significantly different from the nation. So your national school lunch program, this isn't students that are using it, it's students that are eligible for it. There's a difference between these average scores of 31, and that difference is really about the same as the nationwide average of 29, and that's what we mean. This performance gap was not significantly different. You shouldn't try to draw any conclusions saying that, hey, ours was 31, theirs was 29, we're not doing that much worse. The statistics say the gap really wasn't big enough to justify making any changes based on that. Okay, so there was this report, and the next report we're going to look at are the growth charts that if you happen to be a parent and you go to the doctor, you see the doctor throw up there and explain in like 1 minute what that means. We're going to go through carefully, look at those growth charts, and really see what they're saying, what kind of data is presented there. Okay, this is a growth chart, and it's a growth chart we see at the top for boys, age birth to 36 months, and you're looking at length and weight, and you're getting the percentile of those two measurements of the child. And you'll see this kind of a thing if you go and take your child in for a routine checkup at the doctor's office. Actually, I may or may not show you this, but this is what the doctor will be looking at. My doctor usually shows me this chart. Maybe that's because he knows I'm a math teacher, I don't know. Okay, so what'll happen is you'll have some point on the chart. So maybe the point is right here. All right, and what that point does is if you look down, this would be for weight because it's along the weight curves here. If you look down, that's the age. The age is, let's see, 15's right here, 18's over here. So this is 16 months. So the boy is 16 months old. And if I go to the right, okay, that tells me the weight. And let's see if I can follow this line. It looks like it's about right here. Okay, so the child is 1, 2, 3, 4, 5, about 12.6 kilograms and just a little under 28 pounds. 28 pounds is at this level, so they're probably like 27 pounds and 12 ounces or so, because here's 27. Okay, so that's just the raw data, and they measure that. You don't need a chart to tell you that. What the chart does tell you is how the boy's height compares to others of the same age, and that's what these curves are about. Notice that we're between these two curves, and this curve here that we're just above is 75, and it turns out that this curve, it's off the screen so you can't see it, but the curve above it's the 90 curve. So for this age, for a 16-month-old boy, the weight of this child is between the 75th and 90th percentile. And what that means is, let's see, it looks like about halfway in between. So maybe it's about the 82nd percentile. If the child were indeed at the 82nd percentile, that would mean that 82% of boys of the same age are going to be shorter. Or excuse me, this is of weight. The 82% of the boys of the same age are going to be lighter. So this boy's a little on the heavy side, but not a whole lot, because it's only at the 82nd. He's still got about 18% of the boys his age that are heavier than him. So that's what you're saying. And if you're way up here above, this is the 95th percentile line. You'll see that when I scroll up and we talk about height. That means you have a child that's pretty heavy. And if you're down here, you have a child that's pretty light, where they're only heavier than about 4% of children that age. And it's when you get outside of that bounds, those bounds, that the doctor will get a little bit concerned. And it's just a red flag. It doesn't necessarily mean there's anything wrong, but it's something to watch for. You know, if you have a child that's unusually heavy or light, or if you have a child that's unusually tall or short, that's a good thing to watch for and see if there's any explanatory factors that might cause any other problems in the child's health. So let's go up to the length here and plot a few other points, or at least one other point. Okay, so if I plot a point up here, let's say maybe, I need to scroll down so that I can see the age down there. Let's say we take the child in and they're about right here. Okay, take the child, and a lot of times they'll have points from the past, so you know, maybe they'll have lines connecting these. When you see this report, okay, but what we're looking at right now is just one point. This point means that if I bring this down, hopefully I did that right. The child is 30 months old, so they're 2.5 years old. And then if I go to the right, let's see. Now we're no longer talking about weight. Now we're talking about length. So we go to the right and we're right here. Or if we go to the left, let's see if I can match this line up. I think it's that one. We're right here. This is centimeters. That's on the top. You can't see that. And if I scroll up, it'll move all these lines. So I don't want to scroll up. So the child's, it looks like about 88 centimeters, and then is about 34.5 inches tall. And we can see that on this side as well. So that's the raw data. They're 2.5 years old and about 88 centimeters / 34.5 inches tall. But what the doctor is really going to be looking at is how they compare to other children of the same age. For boys that are 30 months old, this child, in regard to length, is at about the 15th or 17th percentile, because it's between the 10 line and the 25 line. So if we were on the 10 line, that would mean our child is taller than 10% of boys of the same age. If we were on the 25 line, that would mean our child is taller than 25% of boys of the same age. So that's what this means. That's what this means. And notice that that's not only based on the height, but it's based on the height and the age. Okay, so I hope that that'll help you interpret these charts, get a feel for what they mean, and I will see you in the next video.